Hey guys, it's Miss Johnson and I'm here to bring you our notes video for Unit 3, Note 6. Today our learning target is I can multiply monomials by polynomials. So let's just review those rules that we've been talking about for the last few days. The product of a power rule where we add exponents when we're multiplying things with like bases. For example, if I had something like x to the third times x to the fifth, that is the same thing as x to the eighth. Power of a power, if I have something inside parentheses like x to the third raised to the fifth power, then I multiply those exponents and I get x to the 15th. And then a zero exponent is always equal to 1. So if I had something like x to the third raised to the 0 power, this whole thing is just 1. Not even x to the first, which is a common mistake. A lot of people want to say that that's x to the first power. It's not. This whole thing, the whole power goes away and our answer is just 1. So that's just to refresh our memories. Now we need to make sure that we also remember how we simplify expressions. So just a refresher on the distributive property. The distributive property is when we multiply a sum by multiplying each term separately and then adding the product. So it's like when we pass that thing that's being multiplied out front to every term that's in the parentheses behind it. So if we're simplifying expressions using distribution, we need to distribute the monomial to each term inside of the polynomial. So we're going to distribute just like we would if they were just numbers. Then we need to multiply each pair that we have, combine any like terms, and make sure our answer is in standard form. We always need to make sure our answer is in standard form. So let's take a look at number 1. In number 1, I have negative 2x squared times the quantity 3x squared minus 7x plus 10. So the first thing I have to do is I need to distribute this negative 2x that's out front to everything that's behind it. So when that happens, I multiply the monomials together. Negative 2 times 3 is negative 6. X squared times x squared is x to the fourth. So I multiplied the coefficients and I added the exponents of the power. Then for the middle terms, negative 2 times negative 7 is positive 14. X squared times x to the first is x to the third. 2 plus 1 gives me 3. Then negative 2x squared times 10 is negative 20x squared. Negative 2 times 10 is negative 20. X squared times no other x's is still x squared. I always make sure that I don't have any like terms. This is x to the fourth, that's x to the third, that's x to the second. I can't put anything together. And I always make sure that it's in standard form. Start with the largest exponent and work my way down from there. So those two things are good. That is my simplified expression. Let's take a look at number 2. In number 2, I have this 5a squared out front that's being multiplied times everything behind it. So when I put the like parts together, when I multiply the monomials, 5 times negative 4 gives me negative 20. A squared times a squared is a to the fourth. Then I have 5 times 2, which is 10, and a squared times a, which is a to the third. Don't forget that that a is actually a to the first there. Then the last one, 5a squared times negative 7. 5 times negative 7 is negative 35. A squared times no other a's is still a squared. No like terms. Powers go 4, 3, 2. I'm ready to go. Let's take a look at number 3. In number 3, I have 6y outside being multiplied by 4y squared minus 9y minus 7. So 6 times 4 gives me 24. Y to the first times y squared is y to the third. Middle term, 6 times negative 9 is negative 54. Y times y is y squared. Last term, 6y times negative 7 is negative 42y. Those are all different terms. I can't combine them because they have different powers. Their powers go 3, 2, 1, which is descending order. That's standard form. Let's take a look at number 4. In number 4, I distribute that negative 3x squared. Negative 3 times 4 is negative 12. X squared times x is x to the third. Negative 3 times negative 8 is positive 24, and x squared times x squared is x to the fourth. Negative 3 times 2 is negative 6, and x squared out front I have no like terms here, but I'm not in standard form. So this 24x to the fourth needs to be in front of the negative 12x to the third. And if you'll notice, this one on the inside wasn't in standard form either. Negative 8x squared was behind the 4x, which those two should have been flip-flopped. So if I write this in standard form, I have 24x to the fourth minus 12x to the third minus 6x squared. If you would have rewritten the original question, putting this and this polynomial on the inside in standard form first and then done the multiplication, you would have already been in standard form at the end. So either way it works, doesn't matter. Let's flip it over and look at the back. So now I am looking at some more multiplying. So I have two sets of distribution going on in number 5, two sets of distribution. In number 5, the first set of distribution is that 4 that's going to go to these two parts. The second set of distribution is that negative d that's going to go to these three parts behind it. So let's take a look at what that would look like. I'm going to get rid of this yucky color on the back because I think it's hard to see. Let's do that. That looks a little better. So when I do that, I have 4 times 3d squared, that's 12d squared. Then I have 4 times 5d, that's plus 20d. Then I have a negative d, or you can call that a negative 1 times d. So negative 1d times d squared is negative d to the third. Negative d times negative 7d is positive 7d squared, and negative 1d times 12 is negative 12d. Holy cow. So now I am going to go back and put my like terms together. I like to start with the largest exponent so that it naturally falls into standard form. So my largest exponent is the power of 3. There's nothing that goes with it, so it's just negative d to the third. Then I look for the powers of 2, and I have 12 and 7, which gives me 19. So 19d squared, and then 20 minus 12, those are also like terms, and 20 minus 12 is 8, so plus 8 times d. Notice, by the way, that when I combine my like terms, my power didn't change. That's just straight back from lesson 1 when we talked about adding and subtracting monomials, or maybe lesson 2. That's my standard form simplified expression. So let's take a look at number 6. In number 6, I have a 3 that needs to go to everything in the front. So I have 15x squared plus 6x minus 12. Then I have a negative x that goes to everything behind it. Don't forget to bring that negative with it. That negative is there. It's going to change the stuff behind it. So negative x times 7x squared is negative 7x to the third. Negative x times 2x is negative 2x squared. Negative x times negative 3 is positive 3x. Negative times negative is positive. So now let's go back and combine our like terms. I look for the largest power. I see a negative 7x to the third. I'm going to write that out front. Then I look for my squareds. There's one and there's one. 15 minus 2 is 13, so plus 13x squared. Then I look for the x terms. Here's a 6, here's a 3, so that's plus 9x. And the only thing I have left is this constant that's by itself, so minus 12 at the end. 3, 2, 1, 0. I'm in standard form. I'm good. Let's try number 7. In number 7, I have that 3 that needs to go on the outside, or that's on the outside that needs to go to everything in the first set. Then I have a 6t that goes to everything in the second set. Be careful when you write t as a variable. It helps if you put a little tail on it so that you can tell that it's a t and not a plus sign, because they look very similar. So 3 times 2t squared is 6t squared. 3 times negative 4t, negative 12t. 3 times negative 15 is negative 45. Then 6t times 5t is plus 30t squared. 6t times 2 is plus 12t. Probably should have said this earlier, but notice, by the way, that as I distribute, my parentheses go away. Once you take care of that distribution, especially if you pull the negative with it when you have that negative there, you don't need the parentheses anymore. Then all you're doing is going back and combining like terms, and parentheses don't change anything in that matter. So that's why I didn't have to rewrite those parentheses anymore. So now let's write this in standard form. I'm going to look for my like terms. I have a 6t squared and a 30t squared. Putting those together is 36t squared. Then I have the t's. I have negative 12t and positive 12t. Those actually are 0. Negative 12 plus 12 is 0, so those cancel out. Then the only other thing I have left is the minus 45, and that is my simplified expression. One last one of this type. First thing I need to do, distribute that x, distribute that 2. That gives me 3x squared plus 4x plus 14x minus 6. Putting my like terms together, I just have these two like terms in the middle. The 3x squared is by itself. 4 plus 14 is 18x, and then minus 6 at the end. That is my simplified expression. Okay, a couple of word problems to look at the bottom here. In number 9, it says Greg pays a fee of $20 a month for local calls. Long distance rates are 6 cents per minute for in-state calls and 5 cents per minute for out-of-state calls. So suppose Greg makes 300 minutes of long distance calls in January and M of those minutes are in-state calls. Find an expression for Greg's phone bill in January. Holy cow. So let's talk about what Greg has to spend money on. Greg has to pay for his local calls. He has to pay for his in-state calls. And he also has to pay for his out-of-state calls. Okay, so let's talk about what those three things look like. The local calls is easy. Local calls is just a flat rate, 20 bucks. The long distance rate is 6 cents. Remember that that's 0.06 of a dollar per minute for in-state calls. And the out-of-state is 5 cents. Remember that that's 0.05 for out-of-state calls. Now there's an M thrown in here. It says, suppose Greg makes 300 minutes, so that's his total long distance minutes in January, and M are in-state. So the M goes right there. Okay, so now let's talk about what these two pieces look like. I know that I have 6 cents per minute for in-state calls and M minutes. So I'm going to have 0.06 times M. That's for my in-state calls. Then the out-of-state calls is a little bit trickier. It's 5 cents per minute, but we don't know how many minutes he had. We do, however, know the total was 300. So if I take the total and I subtract the in-state, that should give me the out-of-state. Total minus in-state is out-of-state for the long-distance calls. So in parentheses, I'm going to take the total and subtract the in-state minutes. That's the expression that I have to work with. Now I need to go back and actually simplify it. So I see some distribution that I have to take care of here. That 20 bucks is still a flat rate. 0.06M, I can't do anything with that yet. Then the 0.05 times 300 gives me 15, and 0.05 times negative M is negative 0.05M. So I've simplified that distribution. Now I got to put my like terms together. I see 20 and 15, which when I add those gives me 35. And I see 0.06M minus 0.05M, which is going to be positive 0.01M. So $35 plus 1 cent per all of his minutes altogether, or for his, I should say for his in-state minutes. That is the expression for his bill. Let's talk about number 10. In number 10, this is going to be a very similar question here. Parking garage charges $30 per month plus, indicator there, 50 cents per daytime hour and 25 cents per nighttime or per nights and weekends hour. It says suppose Wanya parks in the garage for 47 hours in January and H of those are night and weekend hours. Find an expression for her January bill. Okay, so Again, she has three different things that she's doing here. She has the flat rate, so the monthly fee, I guess we could call that. Monthly fee plus the day hours plus the nights and weekends hours. Okay, so monthly fee, easy, 30 bucks. The daytime hours are 50 cents times the number of hours. Now we are told her total, and we're told that H is for nights and weekends. Well, if H is nights and weekends, that means the total minus H is the daytime hours. So I'm going to take the total and subtract H. Then I have the nights and weekends. Nights and weekends are 25 cents. Cheaper to park there on the nights and weekends. Times the number of night and weekend hours, which we were told was H. All right, so there's my expression. Now I just need to simplify it. So again, I see some distribution that I have to take care of. That 30, I'm not doing anything with yet. 0.5 times 47 is 23.5, so 23.5. And then minus 0.5h plus this 0.25h. Put your like terms together. 30 plus 23.5 is 53.5. Then negative 0.5 plus 0.25, this is a negative 0.5 and a positive 0.25, which is a negative 0.25 times the night and weekend hours. So really it's a parking fee minus 25 cents times the night and weekend hours for her January bill. There's the expression. That takes us to the end of our notes video. So don't forget to check off your notes sheet with Miss Johnson. Thanks for listening, and I will see you all later.